Good morning, everyone. Ed Zimmerman here with Ed Talks here at the Detroit Battery Show. Joining you this morning with Martin Plass from the Rochester Institute of Technology. Martin, thank you so much for joining us. Why don't you tell us a little bit about yourself first and foremost, and the great work that you're doing at RIT in support of the industry.
Excellent. Thank you, Ed. Thank you for being here with me and giving me the opportunity.
Absolutely.
So I'm the director for energy storage testing at the RIT Battery Development Center.
Right.
This is a center where we support the industry from the beginning of cell development, so prototyping, through testing, including testing of systems. So all along the development line, we can support the industry. And I've been doing this for 5 years. We were a commercial lab under DNV, business assurance company. Now, since a year and a half, we're part of the RIT Battery Development Center. And it's really a pleasure working with RIT, doing also more development kind of work, but also supporting our commercial customers to help them figure out the right batteries to use for the applications.
Absolutely. Absolutely. So, a lot of the companies that CMP gets to work with, early in their sort of concept phase, as they're considering how to approach the market, cell selection, cell chemistry, cell type, how we're going to arrange this into a module. These are all concerns that they have. And obviously it's a process that can be very time consuming, can be very expensive. How are you at RIT able to support that type of development and selection process?
Well, I mean, for one, often new companies don't often have enough testing capabilities in-house, so we can just provide them the external testing capability to get their cells directly onto test and prove out what they need, maybe before they invest in their own testing infrastructure. Often, even if they do have their own internal testing labs, they often don't have the full capability. We can test not just cells, we can test modules and pack levels, so we can go up to 1500 volts in our testing. So like looking at racks like you're putting in your containers, we can test the full power racks. And so having this capability available to companies, of course, helps them, especially when they're in the startup phase, but also with external expanding their own capability.
Absolutely. Now, one of the things, of course, that we need to understand as we're developing these systems is how they're going to perform over time.
Yes.
How are you at RIT able to help them build out a data set so that they have the confidence that the solution they bring to market is going to meet those requirements?
That's definitely one of our specialties, actually, is we have developed this scorecard testing program that we call it, where you take between 20 and 40 cells and you put them all on test at different conditions. So we test the cells at fast C rates, at slow C rates. We test them at different temperatures. We test them in different SOC windows. We put them in a calendar test where we just let them sit and see how they degrade just by sitting. Like the calendar aging. And we do that for about half a year, and we get a lot of data that you can then use to build a model, and then you can apply this model to different application scenarios. Are you going to cycle once a day, 2 times a day? How deep do you going to discharge? For example, EVs. So they're designed, of course, to maybe have 1 full cycle a week in a normal battery that's driven around 200 miles a week or something like that. Now, if you want to use them as a backup system for your home, suddenly they might be used on a daily basis for 80% of the capacity or something like that. So suddenly a very different application profile. If we have characterized the cells accordingly, we can make a prediction how the lifetime is going to change under these changed application conditions.
Oh, that's fantastic. One of the things you mentioned also is the prototyping capability, right? So, if we're, a new manufacturer looking at new geometries for cell production, for new chemistries, new material types, how are you at RIT with your prototyping capabilities able to support that development?
Yeah. So that's of course more at the beginning of the cell development. So that's more really the cell developers that work with us in that range. And then might be material companies that have some new electrode material or some new electrolyte, and they have maybe one component of what goes in a battery cell that they think is better. So we have all the other components, so they give us a material, we build cells for them in our prototyping lab, and they can start with half cells, with coin cells. We have an automatic coin cell machine, and then we can build cylindrical and pouch cells up to about 40 amp hour capacity. So real full-size
big ones,
cells. Yeah. So really, usable cells, not just
Absolutely.
prototypes, but full size. And then, so these different steps, of course, help to characterize that and then understand, comparing that to existing cells that are on the market, to benchmark them, to see, is this new electrolyte actually going to work better? And then, of course, if they build the bigger cells, we take them in our test lab, and then we can run them through more testing,
Right.
including safety testing. So we shouldn't forget the safety
Of course.
testing.
Absolutely critical.
Yeah.
Absolutely critical. One of the things that, in conversations with you, with your team, with other members of New York Best and NYSERDA, that really sets the RIT team apart is that brain trust that you've developed, right? The depth of experience and knowledge.
Yeah.
Obviously for an organization seeking to test new technology, if they're limiting themselves, just to the team that they've assembled, that could possibly leave options on the table that they're not aware of.
Yeah.
So can you speak a little bit about, the depth of experience and knowledge that you have at RIT based on the work you're doing?
Yeah, of course. I mean, we both, the prototyping and the testing lab, have been in operation over 10 years now.
Yeah.
So there's, of course, a lot of learning we have done over those 10 years. We have been lucky that the staff has been very consistent. So we were able to maintain that knowledge. And so we work with companies to help them develop test programs, help them figure out what's the right combination of the materials is in the prototyping side, how to best design test program or prototyping program, and really help those people develop the knowledge, and then bring them to the next step where they set up their own maybe center and
start
lab
manufacturing their own products or doing their own testing.
Exactly.
That's fantastic.
I mean,
So
the other thing I'd like to mention in that context, we do this battery seminar. So every 2 months we do a battery seminar for about 35 people. It's a 2-day seminar where the industry is sending us new engineers or people related to batteries that don't maybe know that much about batteries. And they come for 2 days. They learn all about how batteries work, how they're being made, how they're being tested, what equipment you use to make them. And they go into the prototyping lab in the dry room, and they actually build some cells themselves.
Oh, wow.
So to me, when I first started doing this 5 years ago, going into the prototyping lab, building a cell, it was eye-opening to understand, okay, it's not just like a little aluminum box, actually to know what's inside, how it comes together, how it's made.
Yeah, seeing how the sausage is made. I think that's really important, right? It's one of these things that, you receive a cell or you design a cell, you're installing a cell, I guess not enough thought is going into how we end up with that product, right?
Yeah,
and understanding, the depth of the supply chain, the manufacturing process, it just adds to that deeper understanding. So, important question, right? You guys are working on, a lot of different chemistries. You've seen, a lot of, new technologies coming to the market. You've supported the commercialization of them. What do you see as the sort of the next breakthrough? Like, what's the next big step that you guys, at RIT within your team are really excited to see?
Well, I think with so many things, it's obviously there's a lot of incremental advances. So lithium ion chemistries, especially LFP, are becoming much more common in a lot of applications, stationary, because they're also safer. Safety is a big factor. So sodium ion, we see a lot of sodium ion cells coming now for testing. And people think sodium ion is so safe. And in fact, we just tested a sodium ion cell that blew up worse than any other cell we've ever tested. So I think this notion that, okay, sodium ion is going to be safe, it depends very much on how it's being built. So there is safe sodium ion and less safe sodium ion chemistries. And I think that's with so many things. Same with lithium metal cells, same with anode-less cells or solid state cells. We see them come in prototype form to our lab. I think we are still far away from that perfect solution. So I don't know if there's going to be at some point this breaks through and suddenly, okay, now we have the golden egg, or maybe it's more like really the incremental process that gets us better and better.
Yeah. Well, I mean, having a lab like yours with your team, with the brain trust that you've developed, and being able to support that incremental improvement over time, that's really, I think, what sort of sets, the ecosystem in New York State apart, and, certainly RIT as well as a major partner in all of that.
Yeah. One thing I maybe want to add to that, I mean, we are lucky that we received some funding from the NSF Engines
Of course,
grant.
absolutely.
And so right now we can do the safety testing on the cell level. With this funding, we're in the process of building a larger safety abuse test facility where we're going to be able to test modules up to about 20 kilowatt hours.
Oh, wow.
And so what that will allow us, and what I believe is really critical for safety, is to look at how the cells propagate and how they're insulated from each other. And so because we know these cells, these especially high energy, high power cells, if that energy gets released in an uncontrolled way, it's pretty dramatic.
Yes.
And we cannot exclude it from happening. It can happen. Things can get crushed, can be defect from manufacturing, whatever.
Of course.
So how you accept that one cell might be failing in a pack, but doesn't propagate to the other cells. I think that's the crux, and that's where the design has to go.
Yep.
And this new facility is going to allow us to do much more of this anti-propagation testing and abuse testing to come to better battery designs and safer battery designs.
That's excellent.
So yeah, we're looking forward to that, and there's
fantastic.
more plans. I mean, we want to build a full-size burn test facility. We're trying to get funding for that, and we want to do failure analysis to a deeper level. We're starting to do some of that, so it's an exciting time, and we're ready to serve that.
There you go. No, that's great. I think that's a great place for us to stop on that focus on safety and incremental improvement, and the way that RIT can support that for companies entering the industry. Thank you so much, Martin.
Oh, it's been a pleasure.
Really appreciate you joining us.
Good.
Very good.
Thank you.
Thanks, everyone.